Oh, future doctors, here is a paper discussion. Some nice way to handle the questions in your very first NEET test. The questions shall pertain to motion in a straight line. We'll begin with the 91st question. This is whenever you see this word train and crossing, there's a very well known and a very reliable way to tackle the question. It is first draw a bridge of the given set length. The bridge length is 850 meters, and always represent the train with not a train as such, which you know, uh, right? Represent a train with just one red line. This red line always shall represent the front of the train. The train shall have two ends. One is the front end and one is the back end. We shall always just see the front end. Okay. So the speed of this front end is always a 45 kilometer per hour, but we have a look at the options. We see that it's in seconds, so we have to convert it. 45 into 5 by 18. We do a quick calculation. 45 and 18, it has three factor in common. So three 15s are, and three 6 are, and three 5s are, and three 2s are. 5 and 2. Otherwise, 45 by 18 has 9. So ultimately, it should be nearly 12.5 meter per second. The train speed is 12.5 meter per second. Having said that, this is the front end. When will I say the train has crossed? When the back end is at, be very careful, when the back end of the train is at this position. If the back end is at this position, then the front end will be over here. What is the length of the train? The length of the train is 150 meters. Be very careful. We say that the train crosses the bridge if the back end of the train is at the leftmost part of the bridge. So, what would be the front end's position then? Front end is obviously 150 meters more, I mean, away from the back end. So, it should be 150 meters over here. So how long did the front end travel? The front end was at this position initially. Now it is over here. So what is the total distance traveled by the front end? 850 meters plus 150 meters. So it is 850 plus 150, the total distance traveled, which has been given to be, which shall be 1000 meters. And what is the speed? Speed is given as 12.5 meter per second. How will I get the time of crossing? Time of crossing is distance by speed, and if you do that, you'll get the answer. It should be somewhere in eights. The only option in eights is 80 seconds. So, how to tackle this? For tackling, we always go with, if you want a formula, I can also take a formula. The formula would be time taken for crossing is length of bridge plus length of train upon speed of train. Length of bridge plus length of train upon speed of train. But if you have to approach it logically, without emphasis in the formula, it should be represent the train with the help of a stick and this vertical line. The vertical line should always be the front end. At the very beginning, the front end is at the rightmost edge of the bridge. After the train has completely crossed the bridge, it would be the back end at the leftmost edge. But I'm not interested about the back end. Rather, I'm interested about the front end. The front end shall be 150 more meters away towards the left. The total distance traveled by the line is 850 plus 150, totally 1000 meters. That is the approach for the first one. The second one, which of the following is a 1D motion? Which this is a classroom discussion question actually. Earth revolving around the sun, two coordinates changes because it is revolution, and landing of an aircraft, two coordinates changes because if this is a runway, aircraft will land like this in an oblique manner. So it is two coordinates is changing. Motion of wheels, if you look at the wheels, wheels are rotating as well as wheels are moving forward. So definitely two coordinates are changing. But for the D option, train running on a straight track, we will model the entire train as one particle. The one particle is moving in a straight line. Only one coordinate is changing, so it should be D. 92 goes with D. The origin of these questions is the NCRT textbook itself, as every NEET question is. So 92 goes with D. What about the 93 one? 93rd one, given X, how will I find initial velocity? A quick approach for this is I see that x and t are related as quadratic. X is dependent on the square of time. That rings alarm bells. And I would want to compare with x equal to ut plus half at square plus x naught, where x naught is the initial position of the particle and u is initial velocity and a is the acceleration. When I compare this equation with this, right? Coefficient of t over here is -5. Coefficient of t in this is u. So I straight away can write u equal to -5. So what is initial velocity of the particle? It should be a, -5 meter per second. Again, what was the, you can do this in another way also. Given x, how will I find v by the traditional method? I can differentiate it. And once I differentiate it, then I put t equal to 0, I will get the same answer. That is a second approach, but a lengthier one. This is a quick one. Whenever distance is related to time as time squared, immediately relate it with x equal to ut plus half et square plus x naught, where x naught is the initial position. Now, 94th one. A particle has an initial velocity of 3i plus 4j, acceleration of 0.4i plus 0.3j. Its speed after 10 seconds is interesting. They have not given the initial velocity magnitude. Instead, they have given it in vector form. So what we would do is we would say v equal to u plus 80, but put arrows atop each of these. So what is v vector? V vector is what we have to find out after 10 seconds. U vector is 3i plus 4j, and acceleration vector is 0.4i plus 0.3j, and then we multiply it with t vector, which is 10. What's the big deal? Well, if we see 0.4i into 10, it becomes 4i. 4i I can add with 3i, make it 7i. 0.3j into 10 will become 3j, 3j plus 4j, it will become 7j. So velocity vector after 10 seconds is 7j, but they're asking what is the speed. Given 7i plus 7j as a velocity vector, how can I find the speed? Be simple, visualize it. How do you visualize 7i plus 7j? 7 components towards the right and 7 components, 7 units above. This is 7i and this is 7j. How will you find the magnitude? Magnitude would be simply the hypotenuse. This is the resultant. 7i plus 7j can be thought of as this vector. That is nothing but square root of 7 square plus 7 square. It should be 7 root 2. That is the 94th question. We can use v equal to u plus 80 not just for speeds and and acceleration magnitude, but also vectorially. All we need to do is express v, u, a, everything in terms of i's and j's. Collect the I coefficients together, j coefficients together, and then visualize it the vectorially, right? In the vectorially. So that would be 7 root 2. Now, question number 95. 95 is currently out of syllabus because they are linking force of 100 newtons, right? Force with velocity. So, how can I get force with velocity? We can just extend our brains a little bit. We can say F is equal to ma, but with a twist. Okay, the twist is mass has been given as 5, force is given as 100, and then acceleration is what we have to find out. So force is given as 100, mass is given as 5, so acceleration will be 20 meter per second square. This is 9 grade stuff, F equal to ma. So we can just identify given our quantities of force and masses. Initial velocity is 20. They're asking what is the final velocity. Applied time is this much, right? What was the initial velocity? U equal to 20. For how much time? T equal to 10. Acceleration is A equal to 20. What is the final velocity? Now, this has become a kinematics question. Given AUT, how will you find VV equal to U plus AT? So 20 plus 20 into 10. So nearly around 220 meter per second shall be the choice, v equal to u plus at. So the only just the very large logical jump you should be required to do here is connecting F, M, and A. Once you find A, connect that A with V equal to U plus 80, and then you shall have the answer with you. So the 95th one goes with 220. Now, what is the 96th one? 96th one given is a T graph. You should be careful. You should look at the quantities labeled first. It is a T graph, and it is beginning from rest. They're asking what is the velocity of the particle at t equal to 3 seconds. All right. So at t equal to 3 seconds. Well, I think this is a typo. It should be, the figure should be somewhere like this, like 4 and that. That should be the figure. So let us assume that is a figure. All right. With this, what is the area under AT graph? Area under AT graph for this would be, this is area under the AT graph. Area under the AT graph always gives you change in velocity. That was the concept, a golden concept. Area gives change in velocity, and whenever you're calculating change in velocity, since velocity is a vector quantity, we always go ahead with the areas above x-axis is positive, areas below x-axis is negative. So you will treat this area as negative, this area as positive, calculate the area that is equal to change in velocity, which is final velocity minus initial velocity. It started from rest, so v minus 0, which gives you v. So this condition is pretty damn important. If it starts from 5 meter per second, 10 meter per second, if they had mentioned, then this should have been v minus 10 or v minus 5 respectively. It is not that. So the initial condition is very important since it is change in velocity which has been asked. So 96th one will be the area, calculate positive, negative, give sign convention, that should be equal to change in velocity. Now, what about the next question, 97th one? The velocity is given as this much. If its position is x equal to 0 at t equal to 0, then its displacement after the unit time is. So they have given v. They want to find displacement x or position x. How do we go from v to x? Flowchart again. From v to x, we have to go. We have to integrate it once. Look at all the options. Every option has no, here is one more typo. It is v naught plus. So every option has v naught, v naught, v naught, v naught in it. The only differentiating factors are, here it is f, it is here g by 2, and here 2g. Okay. So what we do is we have a look at this. Whenever we integrate this expression, you try to integrate this expression, t square is there. T square ka integral will always be t cubed by 3. So in the final, after you integrate, there will always be f by 3 term in the integral. There will always be f by 3 term in the integral. I repeat, once we integrate v naught plus gt plus ft square, from the golden rule we know that integral of t square will give you t cube by 3. So there should be f by 3 in the options, right? In all the options there is f, but only in b there is f by 3. And if you integrate gt, it should be t square by 2. So there should be a g by 2 in the options. Only in b option there is g by 2. So the right choice should be B. We didn't do the actual integration step by step. We just did a very educated guess. The educated guess is, if t square's integral is calculated, it becomes t cubed by 3, so it should be f by 3. T's integral is t square by 2, so it should be g by 2. Okay, so the 97th one goes with D. 98th one, the trigger word is four statements is false. False, not true. So first we should we should check each of them, right? Which of them is true, which of them is false. The false one would be the correct answer. A body can have zero velocity and still be accelerated. Absolutely right. Just like a ball which is thrown up and at the maximum height, the velocity of the particle is zero, but still it is pulled down with g. So obviously A statement is correct. So I won't tick it because I need a wrong statement. A body can have a constant velocity and still have a varying speed. I see there is a problem here because if the we know velocity is a vector quantity, so the direction and magnitude both matters. Magnitude of velocity is nothing but speed. So it can never have a constant velocity and a varying speed. Velocity, it has to be constant, then both the direction of the vector and the length of the vector should be same, should be remaining constant. But if speed is varying, then the length of the vector will change after every time. So therefore, B is false. It cannot have a varying speed. So if it is false, that should be the correct answer for us. So we didn't even read C and D. We straight away can save our time by ticking B. C and D, of course, should be correct. You can verify them yourself. You can read the statements and convince that they are right. I mean, they should hold true. A body can have a constant speed and still have a varying velocity, of course, which is a circular motion definition. Velocity is changing, but speed can be same, uniform circular motion. Direction of velocity can change when its acceleration is constant. Well, velocity's change itself is called acceleration. So if velocity is changing, I say acceleration is there. So even D is true. Both C and D is true. That's it. Now 99th question. Two cars A and B rest at the same time. They are at rest. If A starts at uniform velocity of 40 meter per second, B starts same direction of 4 meter per second square, then how long will it be if B will catch A after how much time? Two bodies, whenever there are two bodies, that would be 99th one calls for the expert relative velocity concept. So I will check A and B like this. A is initially at rest and B is initially at rest. If A starts moving with uniform velocity of 40 meter per second, this is 40 meter per second, and B starts in the same direction with constant acceleration, 4 meter per second square, A is 4 meter per second square, then B will catch A after how much time, right? But there is a problem. Both cars are at rest at the same point initially. So A and B are not separated by any distance. A and B are at the same distance. Okay, A and B, you know, A also here and B also. When will A catch B? Okay. So A can catch B when A traveled after some time. A will be over here at a new position. B should also be there in the new position. Then only they will meet. So the distances traveled by each of them in a time t should be the same. What is the distance traveled by A in time t? Distance of A in time t is nothing but speed of A into time taken, which is 40t, because velocity of A is constant. What is distance traveled by B in the same time? It is initial speed of U is of B is 0 because it was at rest initially. S equal to ut plus half at square, which is half into 4 into t square. So distance of B is covered is half into 4 into t square, where the distance of A is 40t. I equate both. So 40t should be equal to 2t square. I solve this equation. T is common, so t around should be 20 seconds. What is the logic? The logic is initially both of them were at the same point. B didn't have any initial speed. A had an initial speed. They will meet each other when they are at the same position in the same time. Same position in the same time. The distance covered by A is 40t. Distance covered by B is half into 4 into t square. I equate. We get t equal to 20 seconds. Okay, t equal to 20 seconds. So that would be 99th question. And interesting, I haven't used relative velocity because it is the ideal approach for two bodies. You try to solve this using relative velocity approach. The first a step in relative velocity approach is assume fix one body at rest, see how the other body is moving, and then calculate the time taken for the other body to meet this body. Okay, so that would be the time at which both of them are at the same position in the same time. Now, question number 100. A particle moving with uniform acceleration travels 24 meter and 64 meter in the first two consecutive intervals of 4 seconds each. What does it mean? It means this. Uh, uh, don't assume initial velocity to be zero because they have asked initial velocity is what? Immediately, the formula which we can use is S equal to ut plus half at square because S is given, T information is given, U is being asked. Only formula that relates all these is S equal to ut plus half a t square. Then what? S is 24 meters at t equal to 4. So 4u plus half a into 4 square is 16. This is one equation. The second equation is it has traveled 64 meters in the next 4 seconds. So what is the total distance is traveled from the time 0? 64 has traveled in the next 4 seconds. So from t equal to 0, it has traveled 64 plus 24, which is 88. 88 is equal to, and what's the total time? Total time is 4 seconds plus 4 seconds, 8 seconds. 8u plus half a into 8 square 64. Well, you have got two equations and two unknowns. Eliminate acceleration from the equations and find the initial velocity. So this is how you approach 100th question. The only difficult part here is to understand what has been asked. Very many of you would have missed this question because of this first two consecutive intervals. Whenever that intervals question is asked, always take displacement at the end of t seconds. So at the end of first 4 seconds, displacement is 24. At the end of 8 seconds, because for 4 seconds are two intervals, so totally it would be 8 seconds time. At the end of 8 seconds, the total displacement is 64 plus 24, which is 88. So that is question number 100. Whenever intervals are asked, add the intervals to find the total time and add the displacements to find the total displacement. Now going for 101. Speed of two identical cars, U and 4U. The ratio of the respective distances in which the two cars are stopped from that instant is identical cars, identical bullets, identical blocks. Whenever you see identical, the first implication which we are looking at is accelerations of both cars is constant. Constant acceleration cases, right? So if it's constant acceleration cases, how will I find the stopping distance? We use v square equal to u square plus 2as for both of the cars one at a time. For the first car also we use v square equal to u square plus 2as, as well as for the second car also we use v square equal to u square plus 2as. So that would be stopping distance, isn't it? Stopping distance means v equal to 0. We use it for both of them one time each. So it is 0 is equal to u square plus 2as1. For the second car, it is 0 equal to initial speed of the second is 4 times the first. So 4u whole square plus 2as2. Accelerations of both the cars is same since the cars are identical. Now we relate the now we find out the ratios of S1 to S2. Cool. So solve for S1 from this equation, solve for H2 from this equation. When you divide them, you can see that it should be a 4 ka square coming into the picture. So it should be 1 is to 16. Stopping distances are in the ratios of 1 is to 16, right? So there is a result as well. Stopping distances are in the ratio of the square of their initial velocities. I repeat, stopping distances are in the ratio of the square of their initial velocity. Okay. Now, the question number 102. Our body moves for a total of 9 seconds, starting from rest with uniform acceleration and then with uniform retardation, which is twice the value of acceleration. It stops. What is the duration of the uniform acceleration? Question calls for our attention to VT graph. How will the situation looks? How will it look in VT graph? First, it starts from rest and it accelerates, right? It accelerates for some time. Later, it decelerates. It decelerates for some time. Okay. The total time spent from the rest to rest is 9 seconds. It started from rest, it ended back at rest. 9 seconds. What else has been asked? Uh, uh, this is the, you know, what is asked is for how long did it travel in uniform acceleration? For how long was this uniform acceleration, or we want the value of T1. Okay, let me label this theta1 and let me label this theta2. What does the slope of VT graph give? Slope of VT graph gives acceleration. So tan theta1 is the acceleration. Tan theta2 is the deceleration, but they have given the deceleration is twice the acceleration. So tan theta2 should be 2 times tan theta1. Tan theta2 should be 2 times tan theta1. Fine. What is let this side be V. Let this side be V. So what would be tan theta 1? Tan theta 1 shall be V by T1. What shall be tan theta 2 again in this triangle? Tan theta 2 is V by this side. That side is nothing but the whole distance minus T1, which is 9 minus T1. They have told tan theta 2 is 2 times tan theta 1, which means V by 9 minus T1 is 2 times V by T1. So we cancel the V's. We see that T1 should be equal to 18 minus 2 T1, or T1 should be equal to 6 seconds. So the time during which acceleration takes place is 6 seconds. So what is the time during which retardation takes place? When it comes stop, that would be 9 minus 6. So this is 3 seconds and this would be 6 seconds. So this is how life becomes easy if you know how to interpret each kinematics question with a VT graph. And the slope is acceleration, area covered underneath is the displacement of the particle. So that is 102nd question for you. Question number 103. In question 103, two trains are traveling on the same track, approaching with equal speed. They decelerate simultaneously when they are just 2 kilometers apart. What is the value of deceleration to barely avoid collision? So again, we are here on a collision problem. So for collision problem, what did I tell? Only concentrate whenever trains are given, only concentrate on the front end of the train. So let this be the front end of one train and let this be the front end of the other train. The distance between them is given. I think it is 2 kilometers if I'm not wrong. Yeah, they are 2 kilometers apart. 2 kilometers apart. And then um, uh, it is 40 meter per second each speed. So here it is 40. It is going with V equal to 40. Here also it is moving with 40 meter per second. The question is, obviously, if the driver of the red train sees this train, he will apply brakes. He would want to avoid accident. Same goes with the driver of the yellow train. If he sees a red train, he will apply brakes and avoid accident. What should be the acceleration? Remember, acceleration of each of these will be directed like this. Why? Because only if acceleration is in direction, the speed would go down and the train will slow down. They have given both the retardation is the same, A and A each. What should be A such that they barely avoid accident? How to interpret this condition? Barely. Barely means they come to rest while they meet. They come to rest while they meet. At the point where they are very close to each other or touching each other, at that point, they both are at rest. That's a key insight. Now we will use the concept of relative velocity. We will hold the first train to be fixed. The first train to be fixed. I have fixed the first train. What would be the speed of the second train according to the first train? See, both arrows are opposite to each other. This speed, this velocity arrow, this velocity arrow. So they will both add up. So the speed of the second train with respect to the first is 80. 40 plus 40, which is 8. What would be the acceleration of the second with respect to the first? Okay. Again, we see both of them are opposite. Both of them are, can you see their opposite? This acceleration are opposite. So both of the arrows will add up. And the total acceleration of the second with respect to the first is a plus a, which is a 2a. Since I have fixed the first train, how long should the second train travel to meet the first train? It should travel 2 kilometers to meet the first train. Okay. And then how should it look like for the fixed train when it finally touches? While the yellow touches red, yellow should come to rest. When yellow touches red, yellow should come to rest because only then the accident will be avoided. So here it is. Initial velocity of the yellow is 80 towards left, 2a acceleration towards right, and the displacement is 2 kilometers over, yeah, towards left. We'll use sign convention. Initial position is here, final position is there. From initial to final, 2 kilometers is towards left. So S is equal to minus 2000. Reason is it is pointing towards left, sign convention. Acceleration, I will say, is two-way. Acceleration is two-way, positive because it's towards right. What is u? U is minus 80 since its speed velocity is pointing towards left. I want to find the time. What is the time of collision? Okay. So what would be the time of collision in this case? When they meet, I would need first I will find when they meet. They will meet when minus 2000 is equal to minus 80t plus a half into 2a into t squared. Well, they will meet at some time. You can find the value of time by using this. Is that the condition we require? Let us see. There's also one more condition. When the yellow train touches the red train, then speed v of the yellow train should become 0. We can also say v should be 0. How can you find a when you know v, u, and s? We can use v square equal to u square plus 2as. V is 0, u is minus 80, right? And S is minus 2000. So from this, you can find out the value of A required for the trains to just avoid collision. This is also there. So use the two equations. One is find the time of collision, and then from there you can use v equal to u plus at, put v as 0, put this time and find out a. It will require two steps, whereas single step answer is how can I relate v u a s v square equal to u square plus 2a s. Okay, so this is how the train problem can be simplified. You should imagine you are the driver of the train, and then the yellow train will come to rest when it just meets you. So in your frame of reference, you are fixed, only the yellow train is moving. It simplifies a lot of stuff. So that would be your question number 103, relative velocity. Now, what is question number 104? Initial velocity is given, acceleration is given, distance covered by the body in the fifth second. Straight away formula application, Sn equal to u plus a by 2 into 2n minus 1, where n value is given as 5, a is given as 4, u is given as 7. Put the numbers, get the answer. Cool. So question number 105. A body A starts from rest with an acceleration A1 after 2 seconds. Another body B starts from rest with an acceleration A2. They travel equal distances in the fifth second after the start of A. What is the ratio of A1 is to A2? Fine. It is slightly tricky because both the bodies are not starting simultaneously. If they are smart, you should be over smart. How will you become over smart? S equal to u plus a by 2 into 2n minus 1. This, the distance traveled in the fifth second is equal for both of them, but that fifth second of A is not the fifth second of B because B is starting late. So n value you cannot put as 5 for both of them. Key. So how to avoid the problem? If n is 5 for A, for B, n will be 2 seconds lesser than 5. For B, it should be third second. Distance traveled by B in the third second should be equal to distance traveled by A in the fifth second. So n value is 5 for A only and n value is 3 for B, and both of them, for both of them u is anyways 0. Then find the ratios of acceleration. If you put n as 5 for both of them, you will never get the answer. N is not the same for both of them. For one n is 5, for the other n is 3, because B is starting 2 seconds later than uh, A. So for B, only 3 seconds has elapsed. For A, it is 2 extra seconds, 5 seconds have elapsed. Question number 106. What determines the nature of the path followed by the particle? Well, speed doesn't. No, speed doesn't, because I can go with 40 km per hour constant speed in a circle, or I can go with 40 km per hour in a straight line without changing the speed. The speed is same in both cases, but path is different. So speed doesn't determine the path of the particle. It is actually the relation between velocity and acceleration that determines the path of the particle. That would be both B and C. So 106 would go with D. Now 107. 107, displacement is given. Time at which it will attain zero velocity again. You see, initially it was at rest. Again, it will come to rest, it seems. So at what time will it come to rest again? Given X, how will you find V? Given X, how will you find V? We differentiated. So can you find the differential of 6t square minus t cube? It would be 12t minus 3t square. This is the speed of the particle at any time t. When is it equal to 0? It's simple, find it, equate it to 0. You will find it is 0 in 2 points. At t equal to 0 also it is 0, and at t equal to 2 also it is 0. This equation attains 0 value for two values of time, one at t, other at t equal to 2. So when will it come to rest again? It will come to rest again after 2 seconds. Relation, given x, how will you find v? You quickly differentiate. Question number 108. Interesting. Ratio of distance covered by the body during the fifth second to that covered in 5 seconds. Okay. So we know the formulas for both of them. U is anyway 0, A not given. So how will you find the distance traveled in the fifth second? Sn equal to u plus a by 2 into 2n minus 1. Distance covered in the 5 seconds is ut plus half at square. Find the, divide them and find the ratios. Can I do it easily also? Well, I can. First of all, I can eliminate the option of C totally, because distance covered by the body in the fifth second will always be lesser than distance covered by the body in 5 seconds. So the ratio should be less than 1. But here 25 by 9 is greater than 1. So C can't be right. Having said that, A, B, and D all are less than 1. Which one is correct? For that, you need the formula. The formula says 108 1. The formula says Sn equal to u plus a by 2 into 2n minus 1. Put n as u as 0 and n as 5. So S5 is equal to 9a by 2, fifth second. So what is the distance traveled till t equal to 5 seconds? Ut plus half at square, which is half a into 25. When you take a division, don't do the working, just divide them. You see a by 2 goes away, and you have a 9 is to 25 coming in the working. So 108 should be 9 is to 25. Is there anywhere 9 is to 25? No, there is a no 9 is to 25 anywhere. Okay, so it should be 9 is to 25 because u plus a by 2 into 2n minus 1 and half 80 squared, it should be 9 is to 25 and not 25 is to 9. As I see, none of the options are clear. Over. Then, what is 109th question about? 109th question is a famous ball juggling question. So, how many balls are there in the air? How many balls are thrown per minute is what is being asked. One ball is thrown when the previous one is at the maximum height. For all such ones, imagine the first ball thrown, it will reach height 5 meters. When it is going to reach the height of 5 meters, okay, so we know this maximum height. What's the relation between maximum height and time to reach maximum height? We shall see this. H is equal to u square by 2g. Maximum height is u square by 2g. And how will you find the time taken to go there? Time taken to go there is simply u by g. So what is u squared? U squared is h is equal to 5, g is 10. So 20 into 5 is 100, u is 10. If you put u is 10 over here, 10 by 10, time is 1. So the ball takes 1 second to go up. Only after 1 second, the second ball is thrown. So how many balls are there in air, just in air in 1 second? Two balls are in air. So two balls are in the air in 1 second. How many balls will be in the air in 1 minute? 1 minute. Okay. So I will throw how many balls will be there in 1 minute? It will be 1 minute is 60 seconds. So I simply multiply them. So it should be 120. Okay, it should be 120. But you should interpret the question carefully. Have they asked the number of balls in air or have they asked number of balls thrown? You see, at the end of 1 second, how many balls have been thrown? Two balls. So at the end of 60 seconds, how many balls will be thrown? 2 into 60, it should be 120. But if they ask how many balls are in air, well, we know that one ball is in air at the end of 1 second. Other is yet to be thrown. One ball is in air. So after 60 seconds, it will be 60 balls would be in the air. So 60 is also a possible choice if we consider the number of balls in the air. But we are asking number of balls thrown. So it should be double of 60, which is 120. Question number 110. A balloon is rising vertically up with a velocity v. A stone is dropped from it. Dropped from it. You should be very careful when drop comes because you should know whether it is being dropped from a moving object or an object at rest. If it is dropped from a moving object, it will have the same velocity as the moving object. So u is not equal to 0. Instead, u equal to 29. It reaches the ground in 10. What is the height of the balloon when the stone was dropped from it? So, this is the height h. U is a 29 upwards. It will go up and reach the ground in total t equal to 10. Use a sign convention. Initially, it was at the top, now at the bottom. From top to bottom, an arrow. So displacement is minus h. minus h is equal to 29 t minus half g into t square, which is 100. So the only unknown here is h, the height of the balloon when the stone was dropped from it. Sign conventions would save the day. 111. If a ball is thrown vertically up with speed u, the distance covered during the last t seconds of its ascent is. Last t seconds of its ascent is. Best way to go about this is VT graph. How? Let's draw a VT graph for 111. What is a VT graph for an object thrown up? It is this. What does the slope give? Slope gives g, 10. Why is it negative? Because speed is dropping down. Last t seconds means these are the last t seconds of its upward slide. What is the distance covered here? They are asking. So I need to find this area. How will I find the area? We know area is equal to half into base into height. T is given anyway, but height is not given. I will use a condition. Tan theta for this triangle should give acceleration. In other words, h by t is a tan of theta. Tan of theta is g. So h is equal to gt. So you put it over here, we should get half g t square. So distance covered in the last t seconds during the upward flight is half g t square. One more interesting way to look at it is, let us say the ball starts here and goes over there. The distance covered in this t seconds is asked. By symmetry, the distance covered would be the same in this t seconds also. You see, going up t seconds distance is the same as coming down t seconds distance. So what is the distance in the second half of this while it is coming down? For that, initial velocity is 0 because it's coming from the top. It's just coming from rest. So u equal to 0, s is equal to half 8, s equal to ut plus half at square, a is g, we'll get half gt square again. Once again, the distance covered in the first phase, going up phase in t seconds, is the same as distance, it fell in the next t seconds starting from the top due to symmetry. That's also there. Otherwise, you can use the VT graph. And then question number 112. Now, air resistance is taken to be into account to compare the time of rise to time of fall. When the ball is going up, air resistance and its own weight is acting down. So two forces are acting against one velocity. So intuition tells that the brakes, I have slammed hard the brakes of the car. The car is going up. I have slammed the brakes very hard. So what would happen? It will come to rest very quickly. Time of rise is very, very small. Reason, I have applied brakes very strong. Two forces are against one velocity. But while coming down, air resistance is up, whereas weight is acting down. The brakes aren't so hard while it is coming down. But here, definitely the brakes is very, very strong. So the time of rise is small compared to the time of ascent. The time of rise is small than time of descent, so it is less than the time of fall. While falling down, imagine as if somebody is in a parachute, right? Air will resist as well as weight will pull it, but the parachute will land slowly. That is when it is falling down. But while going up, it is both air and weight are resisting it, so it won't go far too much. It will come to rest very quickly. But here it is not. So it will come to rest very slowly. So that is question number 112. Now question number 116. All the graphs below are intended to represent the same motion. One of them does it incorrectly. Pick it up. So all the, three of the graphs tell the same thing. One doesn't. One doesn't. We need to pick that graph. How three graphs should tell the same story, one shouldn't. So we should pick the odd one out. Which graph is odd one? For that, we need to define everything very clearly. We need to describe every graph very clearly. Okay. So velocity versus position, it is this curve. Does this description match with C, position versus time? Does position versus time matches distance versus time and velocity versus time? Yes. Well, we can have a look at this. According to D, just have let's have a look at D. In the D option, velocity time is a straight line. That means it is telling acceleration equal to constant. Acceleration is equal to a constant. But what is the initial velocity? The initial velocity is non-zero. Okay, it is non-zero. But look at the position time graph over here. In the position time graph, initial velocity is not zero because, you know, it started from a high velocity. You draw a tangent, you can see that it started from a very high velocity. So somewhere C and D's details are not matching. The detail of C is not matching with the detail of D, because here initial velocity is assumed to be zero, because here initial velocity is not zero. So C and D, first of all, is not sitting well together. What about B? Here for B, distance time may you can see that at initial time the tangent is horizontal, and as the time passes by, passes by, speed first is increasing and then speed is decreasing. Speed first is increasing and then speed is decreasing. But you know, first speed increases, then speed decreases. But D doesn't tell the same story. Speed increasing, speed decreasing. Whereas this tells the same story. I draw tangents. I see that the slope first decreases and then it increases. So B and C are going well together, whereas B and D are not going well together. So D is not going well with C nor with B. Therefore, D strong, highly it's possible that D should be the odd one out. So we need to describe each graph to the best of our capabilities and then check which one is odd one out. Now let's go to question number 117. Question number 117, VT graph is given. Total distance is asked till 6 seconds. Distance may area should be taken always positive, regardless of whether it is above x-axis or below x-axis. So I first calculate this area. Algebraically, I add it to this area. The total area under the graph will give you distance, provided you don't include sign conventions with it. Okay. So that is it. You first find the area of the trapezium and an area of the triangle. You add both of them without giving a hoot to the sign of those areas. That is 117th question. And what about 118th one? Which graph corresponds to an object with constant negative acceleration and a positive velocity? Negative acceleration and positive velocity. Okay. So again, multiple ways to do it. The simplest way will be negative acceleration means velocity is positive, acceleration is negative. Therefore, velocity should be decreasing with time. But the second one says that velocity is increasing with time. Therefore, B is wrong. What about A? A is saying that velocity first decreases, it seems, and then increases, it seems. And it is not changing signs anyway. what should happen? First, first this V should drop to zero and again raise backwards. Imagine a car which is applying brakes. So once it applies brakes, it will come to zero at some time. After that, it will move in the opposite direction. So velocity should become zero later on. So A doesn't have that characteristic also. Between C and D, between C and D, how to eliminate, how to find velocity versus distance. In both cases, velocity is decreasing with respect to distance. Velocity is becoming very less and less. We will now see A equal to V dV by dx. Acceleration has to be constant and negative. Velocity is continuously reducing. If I have to keep LHS constant, one quantity is reducing, the other quantity should increase. And and what should be velocity is always positive, you see, because velocity is positive given. Velocity is positive, that means dv by dx, it should be negative by default. So there should be a negative slope of dv by dx. Everywhere here the slope is negative, right? And the slope should increase with time. Slope should increase with time. In which of these two cases does the slope increase with time? You can draw multiple tangents. You see here, here, here. Slope is becoming more with respect to distance there, but slope is becoming less and less with respect to distance over here. So definitely C corresponds to the right one. How? A equal to V dV by dx. I should make A negative constant. That would only happen when dV by dx is increasing. Slope should be increasing. At the same time, slope should be negative, right? So that is 118 question C. So the right approach would be elimination and using A equal to V dV by dx. Otherwise, you need to have an advanced understanding of V square equal to U square plus 2AS. V is represented in y-axis, y square equal to some constant k square plus some other, a is negative, some constant k. So minus 2ks is in x minus 2kx. Y square is equal to k square minus 2kx. You should see that this is a parabola. And how, what kind of a parabola? This kind of a parabola. Either you should have an advanced graphical knowledge or you should play with the kinematic calculus equations. A equal to V dV by dx. Good. So we'll move on to question number 120. One car moving on a straight road covers one third of the distance. So one third of the distance is asked. So let the total distance be 3 kilometers. Then one third of it will be just 1 kilometer. Others would be 2 kilometer. And then it covered 1 kilometer with 20 kilometer per hour, 2 kilometer with 60 kilometer per hour. Find the average speed. Average speed is nothing but total distance traveled 3 upon total time taken. Total time taken in the first phase is 1 kilometer by 20 speed, distance by speed, plus 2 kilometer by 60, again distance by speed. So this would be the total time. So you calculate the fraction 3 by 1 upon 20 plus 2 upon 60. You will have the uh, this solved. The best way to solve all this is if they're asking one half, then say that the distance is 2 kilometers. If they're asking one third, say the distance is 3 kilometers, and so on. Now, question number 121. I would say it is a, more of a common sense based. Well, a body is dropped from rest, okay, and there is a line AB equal to BC equal to CD. All these distances are equal. Time to drop this is T1, time to drop this is T2, time to drop this is T3. What is the ratio? What I can say is the body is speeding up while coming down. So to cover AB distance, if it takes T1, to cover BC distance, it takes T2, I can always say T2 should be less than T1. Reason? It is speeding up as it is coming down. So it takes less time to cover the same distance at the bottom, whereas it takes more time to cover same distance at the top. So by that analogy, I can say that T3 should be less than T2 should be less than T1. Which of the options satisfies this? Okay. The last number should be the least, where the first number should be the maximum. This doesn't, because root 3 is maximum with respect to 1. Last number should be the least, first one should be maximum, but first one is not maximum because root 2 is less than root 3, so this isn't. Here, root 2 is neither the least nor the greatest, so therefore C cannot be the right answer. It should be D. Okay. If a body is dropping down, the logic would be to cover the same distance, it will take lesser and lesser time. If I take the ratios, T1 will be the greatest, T2 will be the next greatest, T3 will be the least. Last number has to be the least. That is happening only in the last number is the least. Question number 122. This is a standard PYQ, a NEET PYQ. Time taken by her to walk up on a moving escalator will be. You should know that if T1 is a time taken when she is walking, and T2 is a time taken only by the escalator, T3 is a time taken by her walking on escalator, T3 will be the least, because escalator is also moving, she is also walking on the escalator, so she will reach the top very quickly compared to T1 and T2. So T3 should be the least among T1 and T2. Which of the combinations ensures that? Actually, C ensures that. The T3 is always less than T1, T2. We can relate it to equivalent resistance in the parallel. If two resistors R1, R2, the equivalent resistance will always be R1, R2 by R1 plus R2. This resistance is lesser than the individual resistances. So the overall time she takes, T3, is lesser than T1 and T2. That is being maintained only in C. So C should be the right choice. We didn't use any equations. We just used common sense. She will make to the top very quickly with very less time if she is walking on a moving escalator. So that is 122. 123. A particle starts from rest, has an acceleration of so and so. After it travels for 30 seconds with constant speed and then undergoes retardation of 4 meter per second square comes to rest. What is the total distance traveled by the particle? Distance is given, information on speed is given, acceleration is given. Everything is just right for us to plot the VT graph for 123, which is, it starts from rest, it accelerates, maintains constant speed for some time, and then it decelerates. What is the time for which it accelerates? 10 seconds. What is the time for it travels with constant speed? It travels for constant speed for 30 seconds, and then it undergoes retardation of 4 meter per second square and comes to rest its same. Okay. So what else is given? They have given acceleration and retardation. Acceleration, let this angle be theta 1, let this angle be theta 2. They have given tan theta 1 to be equal to 2 acceleration. Tan theta 2, the deceleration is given as 4. With the help of trigonometry over here, try to find this distance. This distance is the same as this distance. Apply tan theta 1 information here. Tan theta 1 is the, let us call this distance V. Tan theta 1 is V by 10, and that is equal to 2. So V should be equal to 20 meter per second. So this is 20. This is also 20. How will you find this time now? Well, apply tan theta 2 here. V 20 by, let this time be t. 20 by t should be equal to tan theta 2, which is 4. So t is 5 seconds. So here it is, this thing is 5 seconds. Now you have everything that you need. Calculate the area. Area of the triangle. plus area of this rectangle plus area of this triangle would give you the total distance traveled in this much time. That is question number 123. Now, question number 124. Question number 124. The displacement time graph of a particle. What is the sign of the accelerations of the particle OP, PQ, and QR? Well, you see, look at the options first. The common option is B and C. Can you see how many things are common? Plus plus is in common and zero zero is in common. So most likely right options will be between B and C only. The only differentiating factor is the QR plus and minus. You first draw tangent. As you can see, the slope of the tangent is reducing. Slope is reducing means velocity is reducing. If velocity is reducing, it means acceleration is negative in QR. So the right option is C. How did we save time? We looked at the most similar options. Examiner always gives one correct among the most similar options. A and D are most different as it can get. B and C is mostly similar. So we got it. But you may argue even A and D has minus zero. How will we decide? First, again, we draw tangents. You draw tangents over here. You get to see that slope is increasing or velocity is increasing. That can happen only when acceleration is positive. So during OP, acceleration has to be positive. During QR, it has to be negative. So right option should be option B. All right. Now, question number 125. The times corresponding to height h while ascending and while descending are t1 and t2 respectively. What is the velocity of projection? Okay. So you see, this can be simplified. First, it's going up and then it's coming down. Let it be at a height h. While going up, it is spotted at height h at t1 seconds. While coming down, it is spotted at the same h at t2 seconds. Obviously, t2 is greater than t1. They're asking with what speed was it thrown up? With what speed was it thrown up? So what do we do over here? We simply look at it like this. Let us make h 0. If I make h 0, if I assume h is 0, then what is the time at which it is spotted at the very first? At t1 equal to 0, it is at h equal to 0. When will it come back again? It will come back after 2u by g seconds, so that would be t2. If t1 is 0, then t2 should be tu by g. So if I put t1 equal to 0 and t2 equal to 2u by g, I should be getting u as the answer in the options. In the options, if I put t1 as 0 and t2 as 2u by g, I should be getting u itself as the answer. Which one does that? Does A do it? No, it doesn't. Does D do it? Let us see. Let C do it. If you put 2, it will be root T1 as 0. Here it is gone. What about B? Here it is gone. All three options may, if I put T1 0, it will give 0 answers except D. So D should be the right choice. I have substituted H as 0. If H is 0, it will be spotted at that H0 at T1 equal to 0 and T2 equal to 2U by G. So if I put T1 equal to 0, T2 equal to U by G, I should be getting U back. That is not the case in A, B, and C. It is only the case in D. Hence, D is the right choice. Question number 126. I think it is a repeated question. This question has been repeated twice. So again, a VT plot would suffice. We have just discussed question number 126. This one. So they're asking the value of T1 at which it accelerates. This should be 9 minus T1. Theta 1 and theta 2 is given. Tan theta 1 is 2 times. I mean, tan theta 2 is actually 2 times tan theta 1. So we have just done this some time back. The answer should be 6 seconds. The same values. It is not even uh, different. Question number 127. A bird flies for 4 seconds with a speed mod t minus 2. Whenever mod comes, time to go for a graph. What graph? A VT graph. Mod t minus 2 looks like this. This is 2 seconds. It covers a distance of, and this is 4 seconds, right? I just need to find the area under the VT graph. This speed, you put t equal to 0 over here, you get this side as 2. You put t equal to 4 in the equation, also you get this as 2. So this distance is 2, this is 2, this distance is 2, that is 2. Two triangles at the area, so you will get the total distance. Area under VT graph gives you total distance. Okay. Now question number 128. In question 128, a wheel of radius 1 meter rolls forward half a revolution on a horizontal ground. The magnitude of the displacement of the point of a wheel initially in contact with the ground is tricky one. So let us sketch the two positions carefully. This is the initial one, this is the final one. The point of contact initially was over here. After a half a revolution, let it come a distance forward x. So this is just a half a revolution. So the red will be the point of contact now is over here. Uh, what is the displacement? Displacement is the distance between the final position and initial position. So I need this, uh, the length of this. How to find the length of that line? You complete the triangle. Here it goes. The perpendicular is the diameter, which is 2r. And what is the base? Well, we know this. For one complete revolution, the distance traveled by the center is the circumference, 2 pi r. So for a half a revolution, how much it will go? It will go exactly half of it, which is pi r. So the distance traveled by the center in half a revolution, or the base is pi r. Base is pi r, height is 2r, then what will be the hypotenuse? Hypotenuse is square root of 4r square plus, pi r square, and radius is 1 meter. It should have a pi square term within. The option is C. 128 goes with C. Question number 129. A ball which is at rest is dropped from a height h meters. As it bounces off the floor, its speed is 80% of what it was just before touching the ground. What is the new height? Okay. So if you have to look at the physics of this, initially the ball dropped with the u. It from a height of h, uh, it hit the ground with what? We know v equal to root 2 gh. So it hit the ground with root 2 gh speed. It bounced back, not with this v, it bounced back with 80% of this v, or 0.8 root 2 gh. What is the maximum height it will reach? At the maximum height, v is 0. And what is the speed with which it's coming from the floor? 80% of this final velocity, which is root 2 gh. Then what can I do? V is 0. U is zero point 0.8 into root 2 gh. What is the acceleration with which it is rising? Is always equal to minus 10. Can you find out h? V square equal to u square plus 2as. So 0 is equal to u square, which is zero point 0.8 square into 2gh minus 20h, right? Minus 2g minus 2as. So it is g is 10. So 2 into 10, 20h. So from here, I can solve for the value of, it goes to a maximum value of what? H1. I need to solve for H1 actually. Let the distance it rises be H1 minus 2as. So I can get the value of H1 in terms of H as they are being asking. To make matters easy, you can always have a go at substituting the variable. You see, in the question also there is h, in the options also there is h. You can substitute h equal to 1 meter. If you put h equal to 1 meter, calculations will be extremely simple. So that is how you attack question number 129. And what about question number 130? Uh, Very cliche question, very frequently asked question. It covers 2 seconds. In the last 2 seconds, it covers 60 meters. What is the height of the tower? We sketch VT graph. VT graph. Last 2 seconds, it seems. So if I take this is 2 seconds, last 2 seconds may it covered 60 meters. So with the last 2 seconds, area should be 60. The area of this figure should be 60. They're asking what is the total height. Do you remember the total height is total displacement? So for the total displacement, I need, if I name this as OPQR, I need the area of triangle OPQ, the big triangle. That is nothing but the height of the tower. Okay. How will I solve this? Using VT graph. I note that triangle OPQ and triangle OPQRS and triangle ORS, both of them are similar to each other. If they're similar to each other, then the ratio of their areas should be in, uh, correspondence with the square of their sides. And one more thing we know that tan theta of all triangles here is 10. Tan theta is 10. So if I take the big triangle, then also tan theta is 10. If I take a small triangle, then also tan theta is 10. So let's do this. Let's take the areas ratio. Triangle ORS to triangle OPQ area ratio should be equal to, let this time, small time be t. So it shall be t square by t plus 2 whole square. T square by t plus 2 the whole square. Do I know anything more? Yeah, I know a triangle OPQ area minus triangle ORS area. If I subtract them, I should be getting the area of the hatched region, which is 60. Okay, area of the hatched region, which is 60. Uh, what do we get from all this? Um, we shall try to get the area of OPQ now. What is area of OPQ? What is area of ORS? Let's say triangle ORS is triangle OPQ ka area minus 60. Okay. So ORS can be written as OPQ minus 60. Let OPQ thing be called as X. So X minus 60 by X is t square by t plus 2 whole square. What is area X? Area X is half into OPQ, no? OPQ half into t plus 2 distance, t plus 2 base into height. But how will I find height? We know height by base is tan theta 10. So h is 10 into t plus 2. So this is the area. You put the areas over here, you get the value of t. After finding the value of t, find you know, the value of x. So you put x in terms of t over here, you get some equations with the t, solve for t, resubstitute that t over here, you will get the value of x. So this is the approach using VT. You may very well do this using numbers, but always a VT graph practice is going to give you a lot more edge in multiple questions than just algebra. So this is what we do for question number 130. Now, what is question number 131? Question number 131, we have seen a very similar theme, ratio of distance covered in n second to the distance covered in n second. That ratio should always be less than 1. Okay, let us first put n equal to 1. For n equal to 1, it means displacement distance in the first distance traveled in the 1 second to the distance traveled in 1 second. Only for n equal to 1, the ratio should be equal to 1. For all other n values, the ratio is always less than 1. So put n equal to 1 and check where will you get 1. You will not get 1 over here. You will not get 1 over there. Either it is A or it is C. How to go about it next? Now put n equal to 2. Which of the options gives value uh, you know, lesser than 1? Is it A or is it C? Put n equal to 2. If you put n equal to 2, you have in the from the first option 2 by 2, 1 minus 1 by 4. Here it is put n equal to 2. It would be half minus half, which gives you 0. So C is ruled out because it is giving 0 for n equal to 2, but A is giving some number less than 1. So A should be the right answer. You see, if you consider only the first second, the distance and displacement will both be the same. So distance covered in the first second is the same as distance covered in the first in 1 second. But distance covered in the second is lesser than the distance covered in 2 seconds. So for n equal to 2, the ratio should be coming less than 1. That is happening only in the first option. So 131 goes with A. Okay. So what would be 132nd all about? It is moving in a straight line with uniform acceleration observed to be a distance a from a fixed point initially. Whenever too many variables are there, we'll just go ahead and put that distance is 0. So initially the particle was at the origin itself, a equal to 0. It is at distances b, c and d from the same point after n 2 and 3n ante. So I will put n is equal to 1 and makes matter simple. So it is at distance b when at t equal to 1. It is at distance c at t equal to 2. It is at distance d at t equal to 3. What is the acceleration of the particle? I have put a as 0. If I put a as 0, you look at the options, there is no mention of a d anywhere. D is not there. So how can I express acceleration in terms of only B and C? First equation, S equal to ut plus half at square, B is equal to half A into 1 square. For the second thing, C is equal to half A into 2 square, which is 4. How can I express A in terms of, from here I get A equal to 2B. From here I get A equal to C by 2. So what is A in terms of B and C put together? Okay, I will add them. When I add them, 2A equal to 2B plus C by 2. And then I uh, divide by 2. So it should be C plus 4B by 4. C plus 4B by 4. Around. C plus 4B by 4. So if I put n value as 1, then acceleration in terms of a B and C, right? Acceleration in terms of B and C should be C plus 4B by 4. I can see if I put n equal to 1, the denominator coming 4 only in the first case. So it should be highly likely that the option is C. Right. Now we will move to 133rd one. Again a VT graph because we are given information that is from rest, moves with constant speed, comes to finally rest. Ratio of the time taken is this. What is the maximum speed is given and they're asking what is the average speed for the whole journey. So we'll go with question 133. We sketch a VT graph. It is taking the same time here and it is taking same time here. Height of both triangles is same. This triangle, this triangle. Time is also same, which means the angle is also same. The acceleration is equal to the magnitude of the retardation. And the value of h is given to be v value. V value is given to be around uh, um, 60 kilometer per hour. 60 kilometer per hour would be 60 into 5 by 18. You do will get a meter per second. So you know this value. You know the value of this height, right? And t is same. Let this be t1. They have given the ratios of this. This is 1, this is 1, this is 8. They're asking average speed. What is average speed? Average speed is total distance. So first you find the total area, divide by the total time, which is 1, t plus t1 plus t. So let t be k, t1 will be 8k, therefore the other t also will be k. What is the area of the first figure? Area of this triangle is half into whatever converted value you get, 60 into 5 by 18, which is 60 goes with 15 as 60 goes with 6 as a 10, 60, 18 goes with 6 as 3. So it is somewhere around 50 by 3. Okay. Half into, I will call this anyway V, not a number. Half into V into T is the area. But we know half into V into T is the area. And then the other one, the other triangle, it is half into V into T area. This rectangle is V into T1. What is T? T is 8K. What is T1? T1 is 8K. T is simply, I'll put K. This is also K. If I add all of them, I'll get an expression in terms of K's only. So it would be, if I add all of them, half into V into K plus half into V into K plus V into 8K. This is the total area. I will divide it by the total time. What is sum of all the times? K plus 8K, which is 10K. I cancel the K's in the numerator with the K in the denominator. So I'll get the average speed of the thing. Total area by the total time taken gives you the average speed. Speed is nothing but, that total distance is nothing but the area under VT graph. So that would be question number 133. Question number 134. This is a famous question, the case of a very crazy bird. Question number 134. In the question number 134, there is a bird which is moving between two trains. In question 134, again, I will represent a train by a single line only. These trains are approaching each other, this one with V and that one also with V. And then there's a poor a little birdie in the middle. So it is going back and forth with these trains. So the distance between them is given as L. They're asking what is the total distance traveled by our crazy bird, which is going to end its life soon because it's going to be hit by two trains in between, right? Total distance. Total distance will be the speed of the bird into the time taken by the trains to come to each other or hit each other. How will I find the time taken by the trains to hit each other? That is by relative velocity. I will assume that the red train is at rest. So how would it see the yellow train? The yellow train would be moving towards it with 2v because the velocities are opposite, they will add up. And what is the distance between them? Distance between them is L. So what is the time taken for the yellow train to meet the red train? T is equal to the distance L by speed L by 2v. Relative velocities make the concepts very easy. So how long it will be till the yellow train meets the red train at t equal to L by 2, it will meet. The same t you put over here, you'll get the total distance traveled by the bird. You need not consider the many to and fro motions because we know distance is speed into time. You should not consider plus, minus, etc. because they are not asking displacement. That would be too complicated if they ask you displacement. But they're asking just a distance. Distance is simply speed into time. What's the total time till the bird can fly? The bird can fly till the two trains meet. The two trains can meet at L by 2v. So we put it there. You put everything in the right appropriate units, you'll get the option. The option should be 72 kilometers by the way. Question number 135. Here is where again whenever there are many variables, substitute one of the variables appropriately. You will make the job very easy, your life very easy. How? It passes through a certain point above the ground after T1. Let that certain point above the ground will be let it be the ground itself. If you assume itself to be the ground, T1 will be 0. Time after which the body passes through the same point during return journey is nothing but, see, it is thrown up at T1 equal to 0. When will it come to the same point, I mean on the ground again, at T2 equal to 2u by g, because 2u by g is the total time of flight of anything which you throw up. So if you substitute T1 as 0, okay, and if you put T1 as 0 in the options, you should get the total time, which means 2u by g as the answer. If you put T1 as 0 here, you get only u by g. If you put T1 0 here, you get 3u square by g. If you put T1 0 here, you get 3u square by g square. But if you put T1 0 here, you get 2u by g. Hence, this should be the correct option. The time after which the ball reaches the ground, P2u by g, it would be only if T1 is 0. So you put T1 0, you should get T2 as 2u by g. This is life would be simple if you substitute variables as 0. How do you do that? You say let the point be the ground itself. If it's the ground itself, what is the first time at which it will be on the ground? At T1 equal to 0. When will be the next time it will come to the ground? At 2u by g. So if you put T1 equal to 0, you should get option as 2u by g. Hence, 135 goes with the second option. These were the very many, at the first sight challenging, but on a deeper thought, very fun questions to deal with. Your first NEET paper. So I wish you all the very best for your next test. Take care, feel the physics, and have fun with physics. Thank you. Bye bye.